for our last series on ASMR physics. For now, we're going to do another concave mirror. We draw our baseline, like always. Look at all those dashes. It's so many dashes. Now in this one, we're going to draw the object inside the focal length. So just on the inside. Now we draw our lines like normal. The first line is parallel to the baseline, and it travels through the focal point. And I say through very liberally. Now, we label these, as always, 1 and R1. Next, we draw a line that goes through the focal point, but because it can't go through the focal point and hit the mirror, we have to draw away from the focal point, which hits the mirror right there, and then we draw a line that's parallel to the baseline. We label these 2 and R2. Now R1 and R2 do not meet each other in the real world. They diverge, so we must draw them back into the virtual world. So we dash our lines, and then we do it for the R1 line. And where those two lines meet, that is the top of the image. So we draw the top of our pencil. We see it is much larger than it was before. Now we begin the mathematical portion after we realize that this is in the virtual world. Okay, so here comes the mathematical portion. So our P, let's go ahead and just say it's about, I don't know, let's say 5 centimeters. Okay, for Q, we don't know what it is. And F, let's say it's twice what our object is away, so 10 centimeters. Now, we plug in our numbers into our equation. We got 1 over 5 plus 1 over Q, which we don't know, equals 1 over 10. Now we need to get everything on the same side of the equation. So we need to subtract off 1/5 minus 1/5. And we end up with 1 over Q equals 1/10 minus 1/5. Now to get these to a least common denominator, we need to make them both 10. So 1/5 needs to be multiplied by 2 over 2. So 1 over Q equals 1/10 minus 2/10. Now hopefully you can do that math inside your head without plugging it into a calculator. So 1 over Q equals 1/10, but it's negative. Now when we flip it a flop, when we do the reciprocal, we find that Q will equal negative 10 centimeters. Now we check to see that against our drawing, and I don't know, it's a little off, but that's okay. Remember, our drawings aren't perfect. Now, finally, we need to remember that when a Q is negative, it means that it is a virtual image. Now, magnification is always negative Q over P, so once we plug in our magnification here, our Q is negative 10, so we need to make sure that we write that. So negative 10 over 5, which is our P, and that should equal, the negatives cancel, 10 over 5, which is equal to just 2 of them. Now that positive 2, the positive magnification for 2, means that our image is going to be a virtual image, and that is going to be upright. The 2 also means it will be bigger, and it looks like it is. And once again, we find that our image, is in the virtual world. So everything works out